we're going to run through these extra practice examples. So remember, we're going to simplify the left-hand side to make it equal the right-hand side. So the first thing I see is 1 plus tangent squared of x, which makes me think, is that a Pythagorean identity? So we know that sine squared plus cosine squared equals 1. In order to get tangent squared, we'd have to divide by cosine squared. So I'm going to divide the entire equation by cosine squared of x, and we see we get tangent squared x plus 1 equals 1 over the cosine squared, which is the secant squared of x. So we can replace the entire top portion with secant squared of x over cosecant squared of x. Well, and let's remember secant squared of x is 1 over cosine squared of x. Cosecant squared is 1 over sine squared of x. But we don't like to divide by a fraction. Instead, we multiply by the reciprocal. So the denominator that we're dividing by, that fraction, 1 divided by sine squared of x, we multiply by its reciprocal. And so we end up with sine squared x over cosine squared x, which equals the tangent squared of x. Remember, there are multiple ways to do these problems, so you might have done it a little bit of a different way. As long as your steps are all true mathematical statements, you're fine. All right, so on this next one, we've got sine of x over the cotangent squared of x. Remember that 1 over the cotangent squared of x would be the same as tangent squared of x, so I can bring that up as tangent squared of x. And then we've got cosine squared in the denominator there, so if we bring that up, that would be the secant squared of x. And so now if I factor out the common factor, so both of these have a sine of x. If I factor that out, I'm left with tangent squared of x minus secant squared of x, which is a modification of that Pythagorean identity we found up here. So if I subtract the tangent squared over, I'd have secant squared x minus tangent squared x. So we're just the opposite sign of what we need, so we can take out a -1 and have negative sine of x times the secant squared of x minus the tangent squared of x. We also kind of had a clue we needed to do that because somehow we needed to end up with the negative sign. But so now we've got, that identity, because again, if I subtract tangent squared x over here, I see that 1 equals secant squared x minus tangent squared x. So I can simplify that right-hand side, negative sine of x times 1, and so we in fact get what we had there on the right-hand side, negative sine of x. All right, so on the left-hand side, we've got secant of x plus 1, which actually, let's go ahead and write that. Remind ourselves, secant is 1 over the cosine of x plus 1. Tangent is sine of x over cosine of x. So if we multiply by the reciprocal, rather than dividing, so that's the numerator. So rather than taking that and dividing by sine of x over cosine of x, let's multiply it by cosine of x over sine of x. And so when we distribute this in, for the first one, we're going to have cosine of x divided by cosine of x, so that's going to be 1. And we're going to end up with 1 over the sine of x. And then we're going to have cosine of x over sine of x. So they'll have a common denominator, so we can go ahead and add those together and say 1 plus the cosine of x over sine of x. And so now I'm going to use a little trick. So, I kind of want the reciprocal of what I've got now, and I want 1 minus cosine of x rather than 1 plus, which makes me feel like maybe we need to end up with difference of squares we can factor so that we could cancel out this factor and be left with this. And the way I can get that is with Pythagorean identity. I know that sine squared would equal 1 minus cosine squared of x, which would be difference of squares. I could factor, cancel this out, and be left with that. But to get it, I need sine squared. So I'm going to multiply the top and the bottom by sine of x. I'm not even going to multiply it in the top. I'm going to keep it in factored form. But now I can replace that sine squared of x with 1 minus cosine squared of x. And 1 minus cosine squared of x is difference of squares. So I can factor it as 1 plus cosine of x times 1 minus cosine of x. And so then that divides out, and I am left with sine of x over 1 minus cosine of x, which is exactly what the right-hand side said. All right, so I think on this one we're going to go ahead and get a common denominator to put these together. So I'm going to multiply this one by cosine of x over cosine of x, and this one by sine of x over sine of x. So we would have cosine of x plus cosine squared of x over sine of x cosine of x plus sine squared of x over sine of x cosine of x. So now that they have a common denominator, we can go ahead and add them as one fraction rather than separate fractions. So we know sine squared plus cosine squared equals 1. And there we have it. Cosine of x plus 1 over sine of x cosine of x. All right, so let's put this in terms of sine and cosine. So tangent is sine of x over cosine of x. Cotangent is cosine of x over sine of x. So if I want a fraction bust, I've got to multiply top and bottom by sine of x cosine of x. Which, remember, is like over 1. It's going to affect the numerators. But we've got to make sure we distribute to every term. So we'll have sine of x cosine of x plus sine squared of x, because the cosines would have divided out. In the bottom, we've got sine of x cosine of x plus cosine squared of x, because the sines would have divided out. So in the top, we can factor out a sine of x, and we'll have forgetting to number my steps, sorry. So then we'll have sine of x times cosine of x plus sine of x. In the bottom, GCF is cosine of x, so we can take that out and have sine of x plus cosine of x. And although they're written in the opposite orders, addition is commutative, it's the same value, so these are going to divide out and leave us with sine of x over cosine of x. But remember that sine of x is equal to 1 over the cosecant of x, and cosine of x is equal to 1 over the secant of x. We don't like to divide by fractions. Instead, we multiply by the reciprocal. And so there we have it, secant of x over the cosecant of x. All right, let's go ahead and multiply out this left side. Remember, anytime you have a binomial to a power, you've got to write it out 2 times. and use Euler box. So we're going to get 1, we're going to get tangent of x plus tangent of x, so that's 2 times the tangent of x, and then tangent of x times tangent of x equals tangent squared of x. All right, well, let's rearrange a little bit. Let's write it 2 tangent of x plus 1 plus tangent squared of x, because remember those Pythagorean identities. We know that 1 plus tangent squared of x equals secant squared of x. So we can replace it and say 2 times the tangent of x plus secant squared of x, which is what they asked us to prove it as, just written backwards. But again, addition's commutative. All right, so number 7, let's go ahead and write this one in terms of sine and cosines as well to see where that leads us. So we've got 1 over sine of x minus cosine squared of x over sine of x. So they already have a common denominator. We can go ahead and combine them into one fraction. 1 minus cosine squared of x over sine of x. Well, 1 minus cosine squared is really sine squared of x over sine of x. And so one of those signs will divide out from top to bottom, and we're just left with sine of x. All right, number 8. Again, let's try writing these in terms of sines and cosines. So remember, secant is 1 over the cosine squared of x, and then we've got sine squared of x. And so if we multiply those, we've got sine squared of x over cosine squared of x, which is the tangent squared. And again, we figure this out. Those Pythagorean identities are so important. Tangent squared of x plus 1 equals secant squared of x. So this just equals secant squared of x. All right, so again, let's try writing this in terms of sines and cosines. So it's 1 over cosine squared. Here I'm going to factor out a 1 so that I can have sine squared plus cosine squared. So maybe I didn't want to write that as 1 over cosine squared. Let me take that back. If I take it back to secant squared of x minus 1, because sine squared of x plus cosine squared of x equals 1. Let's check that Pythagorean identity again. Yeah, so if tangent squared of x plus 1 equals secant squared, we could subtract the 1 over. Secant squared of x minus 1 would equal the tangent squared of x. And so we've already got it. That's what we were trying to get to for that right-hand side. And so we've done it. All right, so let's go ahead, write them in terms of sine and cosine, see if that helps. There is a GCF, but I'm not sure if we want to use it yet, so let's try this first. All right, so cosines are going to divide out and just leave you a sine of x here. And here we're going to have cosine squared x over sine of x. And then if we distribute it in the sine, we will have sine squared of x minus cosine squared of x. But remember, we could rewrite sine squared as 1 minus cosine squared of x, since sine squared plus cosine squared equals 1. And so then if we combine like terms, we've got 1 minus 2 cosine squared of x. All right, on the left-hand side here, let's multiply these binomials. This is difference of squares. So 1 times 1 is 1. Outside would be positive sine of x. inside is negative sine of x, and then negative sine of x times sine of x will be negative sine squared of x. All of that is being multiplied by secant of x, which I'm going to go ahead and write as 1 over cosine of x. So what we really have is 1 minus sine squared of x times 1 over cosine of x. Well, we know that 1 minus sine squared is equal to the cosine squared of x. And if we multiply that by 1 over cosine of x, we've got cosine squared of x over cosine of x. So one of those cosines will divide out from top to bottom, and we're just left with the cosine of x. All right, number 12. Again, let's write them in terms of sine and cosine. So cotangent is cosine of x over sine of x. Tangent is sine of x over cosine of x. Over that denominator, sine of x, cosine of x. So I'm going to go ahead and get a common denominator on the top. I'm going to multiply this one by sine of x over sine of x. This one by cosine of x over cosine of x. So that I've got cosine squared x over sine of x times cosine of x minus sine squared of x over cosine of x sine of x over that denominator sine of x cosine of x. So if we put them together as a single fraction, we've got cosine squared x minus sine squared x over our common denominator sine of x cosine of x, all being divided by the sine of x cosine of x. We don't like to divide when fractions are involved. It's not a defined operation. So if we rewrite it, so we've got cosine squared of x minus sine squared of x over the sine of x cosine of x. And rather than dividing by sine of x cosine of x, we're going to multiply by its reciprocal, which would be 1 over sine of x cosine of x. So we will have cosine squared x minus sine squared x over sine squared x cosine squared x. And so if we individually divide then, cosine squared x over sine squared x cosine squared x minus sine squared x over sine squared x cosine squared x. So in that first fraction, the cosines divide out and you've got 1 over sine squared x. In the second one, the sine squareds divide out and you've got 1 over cosine squared x. Remember, 1 over the sine squared would be the cosecant squared of x, and 1 over cosine squared would be the secant squared of x. So there we go. And remember, there's multiple ways to do this. So if you saw a faster way to do that one, that's great, that's fine. We just have to use true mathematical statements and end up in the right place in the end. All right, so take a look at our other Pythagorean identity. So the basic one, sine squared of x plus cosine squared of x equals 1. So if I want to get cotangent, I would have to divide by sine squared of x. So that I had cotangent squared over sine squared. So I have 1 plus cotangent squared of x equals the cosecant squared of x. And that's helpful because I can subtract the 1 over and have cotangent squared of x equals the cosecant squared of x minus 1, which means I could replace that cotangent squared of x in the top with cosecant squared x minus 1 over the cosecant of x minus 1. And the top is difference of squares, so I can factor that as cosecant x plus 1, cosecant x minus 1 over the cosecant of x minus 1. And so then these divide out, and we are left with cosecant of x plus 1, as we were supposed to be. All right, so that was just a whole bunch more examples. Hopefully they're helping you to gain some experience, gain some tips and tricks, and start to feel more confident about these.